before class.
Okay, I'm ready. I don't remember what it was, but please give it to me. I didn't write solutions yet. That's why I don't remember.
Okay. It would be this function is f of x equals x squared plus 1 over 3x minus 2x squared.
Perfect.
Then you can simplify that into x squared plus 1 over x open parenthesis 3 minus 2x close parenthesis.
Always descending order. This should be a habit. And always factor out the -1 if the leading coefficient is negative.
Okay, thank you.
We always recommend that. Good. Next step. What was the question? To find, if I remember correctly, the vertical asymptotes?
Yes, to find the vertical asymptotes and then find the limits of each.
Very good. So first of all, there are two restrictions here. And let's see who's going to give them to us. Okay, Killen? Are you with us? 1, 2, 3?
Yes, I'm trying to pull up the homework though.
It's right here in front of us.
Okay. I got 3 halves, 3 over 2, and x equals 0.
Excellent. Well done. Very good. So since these two, 2x minus 3, does not cancel out with a factor of 2x minus 3 from the top, we know that, and x does not cancel out, simplify with a factor from the top. Would you agree, everyone?
Yes.
Okay. Then these must be vertical asymptotes. No question about it. They don't disappear. The factors don't disappear. So they have to be vertical asymptotes. At this point, we have to find the limit as x approaches 0 from the left, limit as x approaches 0 from the right, limit as x approaches 3 over 2 from the left, a limit as x approaches 3 over 2 from the right. From, of course, negative x squared plus 1 over x 2x minus 3, and the same all over. We've done this in pre-calculus all the time. It's just that now we know this operator that we have not used before. Everything is the same. Okay? So I know that when I plug in 0, the numerator is negative and the denominator is 0. The numerator is negative and the denominator is 0. The numerator, no matter what I plug in, is positive but with negative in front, and the denominator is 0. Negative again and 0. Would you all agree with this?
Yes.
Anyone? Any questions?
So where does the 0 come from?
Didn't we say that when the denominator is 0, we get x equals 0 and x equals 3 halves? How did we get these?
Oh, from them not exist, or from them being asymptotes.
No. The vertical asymptotes come from the fact that the denominator cannot be 0.
Okay, thank you.
So I highly recommend, please, and I don't mind begging my students, rewatch the videos. That's why I stay up till midnight to upload them for you. You have a lot of information there that during class you may miss. I'm trying to involve everyone in the learning process, but I can't 20 students all the time. So it will help you tremendously if you rewatch at least some of the videos or parts of those videos. Okay? Because everything was discussed in class and how we get the vertical asymptotes. it will save you a lot of time. Okay, so knowing that all of them have a number over 0, they are all infinity, positive infinity, negative infinity, or DNE. Because we know that a number divided by 0 has absolutely no hope for the limit to exist. So now I will plug in a number from the left, which is negative 0.1. So the numerator is still negative. The denominator with negative 0.1, this will be negative with negative and negative. So this will turn out to be negative. So it's infinity. With 0.1, this is positive. This is negative, right? So this was negative and negative. So this was positive with negative in front. Right? So it's negative infinity, because it cannot be the same in this situation. So this is negative infinity, right? So it's positive here. So the top is negative, this is negative, and this is negative. So both these two factors are negative. So that's why the denominator is positive. So then this is negative infinity. Here I have positive, but with 0.1, this becomes negative. So then this is indeed positive infinity. Okay, with 1.5 from the left, like 1.4. The numerator is still negative. This is positive. But 1.4 times 2 is 2.8 minus 3, it's negative. So the negative with the negative will be positive infinity. And the last one, this is with 1.5. 5. So this is positive. The numerator is negative. This is with 1.55 will cover this. So this will be positive. So this is negative infinity. Any questions?
Yeah, so I thought when the limit was either infinity, it did not exist.
Yes. But I also mentioned that we can never write DNE unless the left and the right are different. We're not interested in the limit from either side. When we determine the limits, it's a very good question actually. When we determine the limits left and right of a vertical asymptote, where we know that the limit from either side is positive, negative, or DNE, but we don't care about that. We care about the limit from the left and the limit from the right.
Okay, I got it. For some reason in my head, I had it that all of those were from either side, but now that you explain it, I see that it's...
But it's a very good question. So even if I have this, so this limit is indeed infinity. And if I have this limit is indeed negative infinity. But if I have this is DNE. But this is DNE as well, but I cannot write DNE. I have to write infinity. This is DNE as well, but I cannot write DNE. I have to write negative infinity. And this one is DNE. We are not, when we talk about vertical asymptotes, we are not interested from either side. We are only interested from the left and from the right. From the left and from the right. Very good question.
Thank you.
Thank you. Is this better? Okay,
Yes,
perfect. Next question, is there anything else for me?
When we're writing the limit, are we supposed to use the function? Sorry. When we're writing the limit, are we supposed to factor the function?
You don't have to. It's easier for me. I'm lazy. I don't want to plug in this in here. Oh, no. I prefer plugging in the product because it's so much easier. But you can say, I don't want to factor because I'm going to use the calculator and plug in negative 0.1 in the calculator. That's fine too.
Okay, thank you.
But for me, when I explain, it's easier than grab the calculator and show every little thing that I plug in this and that. It's so much easier. But you can use the calculator, of course. And you don't have to factor. I like everything factored. I liked everything in the descending order. Because if I factor it, then I see whether a factor disappears. But if I don't factor, I may miss Actually, I did have a problem like that on a test last semester. Students did not factor, did not simplify, and it took them 3 pages to find the derivative, and they didn't find it. And it was just one line. Okay, it was just one line. The derivative was in less than one line, and it took them 3 pages, and they couldn't find it. Only because they didn't do this from the very beginning. Descending order and factor. If it's a negative leading coefficient, or if it's something that I can factor, I will always factor from the very beginning. It's a very good question. Thank you. Always remember, and I say this in all my classes, your questions not only help you, but help me be a better professor, because I can't think of all different things to say sometimes. I'm trying to cover them all, but every group of students is different. Every student has different needs and different questions. So if you don't communicate with me, I will not be able to clarify things that may not be 100% clear in class. So always, I commend you for asking questions. That's why we're here, because you can learn this on YouTube, right? But we are here because I'm hoping for your questions, of course. Okay, thank you. Next question. Is there anything else? Do we have anything else? Okay. Do we need, when I was just starting a conversation, I was getting ready to get into WebAssign to see if we can access now the book. Yesterday, for some reason, with another class in a different system, not WebAssign, I just could not access the book. I have it here, but I just wanted my students to contribute as well. So they couldn't contribute because we couldn't access the book. Okay, so I consider 2.2 completed, but if you think we need other examples, let's look and let me know if you need anything else. Where's my keyboard? Here. And let me know. Do you think we need other examples with infinite limits? There are other examples with other functions. Okay, I'm finally in, I think. If it lets me in. And I'm going to the ebook. I can show the book I have, but the book I have is an older edition, so that's why I wanted to go directly to our book. I'm sharing the screen. Okay, sorry guys, I have to move you. Okay, let's look at least one more infinite limit. We looked at a few, but maybe not enough. We looked at ratios. We looked at natural log with an example. Let's see, anything else interesting? We may want to look at secant x, or 35 or 36. Okay, so let's look at just one more. Let's look at 36. Ready? Any questions for me? Okay, so 36, and this is still in 2.2. Oh yeah, I changed this and I didn't copy. Okay, here it is. So limit as x approaches pi over 2 from the right of 1 over x secant x. As we said, what do we need to do first? Lindsay, what do we need to do first when we determine a limit?
Is that to figure out or set it equal to pi over 2?
In other words, replace, yes, we plug it in. We replace x with pi over 2. It doesn't matter if it's from either side, left or right, we replaced x with pi over 2. And yes, you could say, but you're not allowed to. That's correct, but still we have to, to see what it is. Okay, so what about secant of pi over 2? Can anyone give us the definition of secant? We try to use simple functions. Trey, will you tell us what is secant x? What does it equal to? Okay, Trey's not here. Trey's not here.
Isn't 1 over 2?
So secant x equals 1 divided by cosine x. That's the definition of secant. So it's always easier to see what happens here. So now let's plug in pi over 2. Javon, do you remember how much is cosine pi over 2? Javon, are you with us?
All right, is it 0?
Cosine pi over 2 is 0. So then we have here 1 over 0. Very good. Cosine pi over 2 is 0. So this is a number. It's pi over 2. When I flip, this will be 2 over pi. So all this expression will approach 2 over pi. Who cares? It's just a number. So there is a number over 0. So a number, whatever that is, divided by 0. Is there hope for the limit to exist? Mickey?
No.
No. Excellent. The limit will not exist. So the options are, anyone? Yin? What are the options when we have a number over 0?
Negative infinity, positive infinity, and
Excellent. Good. So now we don't know which one it is. It's not D and E. So pi over 2 from the left. Let's take a look. So here's pi over 2. Pi over 2 from the right is an angle right here in the second quadrant. Pi over 2 plus means higher, a higher number of radians than pi over 2. Pi over 2 minus would mean first quadrant, but pi over 2 with plus means the second quadrant. Now we have to remember the top, it's a positive number. We have to remember the sign of cosine in the second quadrant. Okay, so Jordan, would you tell us the sign of cosine in the second quadrant?
Negative.
Very good, awesome. It is negative. So then what is the answer? Sarah?
Would it be negative infinity?
Great job. Which automatically means India. When the limit of a function, when x approaches whatever, gives us negative infinity or positive infinity, what do we conclude?
It gives us negative infinity.
That x equals pi over 2 is a vertical asymptote. Good. Moving on. Do we need more examples? Are we okay?
Can we do one more?
Okay. And I'm hoping you are going to watch this again before you start your homework. That's my hope always. Okay, here it is, number 40. In number 40, we have limit as x approaches 0. from 1 over x minus natural log x.